GEOGADKA. Webinaria.
Hello everyone, I'm Tanmay Keuskar, a PhD student, and my research area, as said by Agatha, mostly the geology of the Arctic area. I focus on the geochemistry and uranium dating. But today, I'm going to talk about shaping the Earth, insight into the plate tectonics. Plate tectonics is a mechanism which is working inside the Earth and shaping the face of the Earth, the crust of the Earth where we are living. So it's directly affect our day-to-day life. There are many phenomena which are associated with the plate tectonics. While living on the Earth, we face many such phenomena, many disasters, many things which happen around us, but we don't know why this happened. So let's start looking at some of the news from recent history. So there was a great earthquake in San Francisco in 1906, which killed almost 1,000 people. And we can see in the photograph below that the city of San Francisco was completely destroyed during this earthquake. Similar, in 1991, there was a big volcanic eruption at Mount Pinatubo, and it caused the death of around 800 people, and around 16,000 people were evacuated from the area around it. It caused a large amount of destruction of the infrastructure, as well as destruction of the normal life of people. In 2004, Asia was smashed with a tsunami and many people lost their life. You can see a photo where a lady in India is finding out his husband who is lost or maybe died, and she's looking for whether he's alive or not. There was also a cricket match happened after this to raise some fund to help the people which were affected during this. So what might be the reason why things like earthquake, volcanoes, or tsunamis were happening and still happening around us? Previously, there were many thought processes about it. So let's quickly look what are the legions which are associated with this phenomena. So Japanese people think that there is a big catfish called as namazu, or with more respect, onamazu, which is below the island of Japan. And whenever this naughty fish move, it causes seismic tremors. And Kashima, a god in the Japanese culture, he's having a big stone over this catfish. And whenever this god is distracted because of his some affairs doing something, this cat just move and this causes an earthquake. According to Hindu mythology, the earth is balanced by four elephants, which are standing on a big tortoise. And whenever any of these animals move, there is a big tremor, and that causes an earthquake. Similar stories are associated with volcanic eruption. According to the Roman mythology, there is a Roman blacksmith of the Roman gods, which is Vulcan. So whenever Vulcan is making equipments for gods or weapons for gods and using his workshop, he just spill out the fire, and that caused the volcanic eruption. While in Hawaiian culture, the god is Pele, who is a bit angry and tempestuous woman. Whenever she is angry, she just explodes out and there is a large eruption. But when we look into the recent scientific discoveries, like if we see the photograph of the Earth, we can see there is no one holding Earth. There is no big elephants, or there is no big snake which is holding this big Earth, or there is no such Pele, or there is no Vulcan inside the Earth. So again, the question arises: why things are happening? And everyone is confused. Layman is confused why such things happen and how it is associated with Earth. There was one guy who might know the answer, though he didn't say that earthquakes or volcanoes are happen because of what he's proposing or what is his idea. But he was the first who said that the continents on which we are today living are not stationary, but they are moving. The name of this guy was Alfred Wegener. He was a meteorologist. geophysicist and geologist. He found some evidences based on which he wrote his hypothesis called as the origin of continent and oceans, which was a big news during that time of scientific community. Many people oppose him because of the idea, but that was the starting of a new era or new theory which start to build up after Alfred Wegener. Even before Alfred Wegener, many people suggest that there might be chances that continents and oceans are moving, but no one was having a proper evidence. But Alfred Wegener was the first to propose the idea with the firm evidences, and therefore he changed the path of the history and start to develop a new hypothesis and new theory. So let's look a small documentary about this guy, which is Alfred Wegener.
Germany, 1911. A meteorologist named Alfred Wegener was browsing through some books when something caught his eye. A list of identical plant and animal fossils that had been found on opposite sides of the Atlantic Ocean. Wegener was intrigued. How could the same species have gotten from one part of the world to another? He examined the eastern coast of South America and the western coast of Africa and was struck how the shapes of the two coastlines might fit together. The more he looked, the more links he found. Species of land mammals in East Africa also inhabited the island of Madagascar. How did that happen? Did the animals evolve in both places at once? Or did they somehow cross from one land to the other, swimming hundreds of miles across the Indian Ocean? And then Wegener saw it all clearly. He realized that all the continents in the world had once formed a giant single landmass that he called Pangaea, from the Greek Pangaia, meaning all earth. It was in Pangaea that the plants and animals found on opposite sides of the world had once shared the same home. Then, over hundreds of millions of years, Pangaea had split apart, and its jigsaw pieces had drifted to their present locations. Wegener called his theory continental drift. Wegener wasn't the first scientist to speculate that the Earth had once been dominated by a supercontinent, but he was the first to pull together all the evidence and make a strong case for it. Unfortunately, his peers weren't very receptive. There was no mechanism to explain how the continents might plow through the oceans. Continental drift was just too incredible to believe. As a result, his discovery was largely ignored.
So Alfred Wegener is the first guy who proposed this theory of continental drift. It was highly criticized, and though there was a fossil evidences, many people actually say there might be more ways this migration of fossil might have. And therefore, this is one of the funny cartoons made by Holden, which illustrate how animals can cross the large sea between two land masses. One can be by rafting. It can be a bridge between the two continents, which is submerged today, or there might be some stepping stones on which animals like unicorns can jump. But Alfred Wegener was very firm that it is a continental drift. What he observed, basically, to sum it up, that if we see the continents, they fit exactly like a jigsaw puzzle. So he mostly focused on the South America and Africa, which fit exactly, which is highly criticized because of a correct reason that it is under the shoreline of the continents are getting modified regularly because of the deposition, erosion. So what we have today might not be present many years ago, and therefore this such correlation is not possible. Second thing, he observed that some mountainous ranges are continuous from one landmass to another, crossing the river, crossing the ocean. And the most important for him was the fossils, which are distributed in part, which are far, far away from each other, like Mesosaurus, from South America to Africa, or Glossopteris, which was from which was present in South Africa, Antarctica, and also Australia. So based on this observation, he hypothesized one great continent, which he called as Pangaea, which means the whole Earth or all the land. And this is the sketch recreated from 1912 published book of Wagner, which fit approximately similar to what we know today Pangaea used to look like. So Wagner was pretty good, but it was highly criticized. And in one of his expedition to Greenland in 1930s, I think he went for the long walk and like for the expedition, and then he never returned back. He died in there somewhere, but his legacy still remain and his theory was still there. Some people were thinking that it is right. Boost to this theory was happened after Second World War. During Second World War, many great nations understand the importance of submarine war, use of submarine, and for that they need to know how the ocean floor look like, and that thinking evolved into a really good, precise bathymetry, and that bathymetry gives us some good idea about continental drift, which was proposed by Wagner. So we can see one of this ship called as Glomar Challenger, which is whose purpose was to drill the core inside the ocean floor, as well as do the bathymetric survey using the sonar. And at that time, Tharp and Hazen, these two scholars, they found out there is a ridge system which is going around, and Tharp is the one lady who said that it is possible that there is a breaking of the ocean at this position and creation of a new ocean around it, which is called as seafloor spreading. So let's first see how the sonar works, like how we measure the bathymetry or the depth of and the morphology of the ocean basin.
Single beam sonar works by emitting a sound wave and listening for how long it takes to return, like an echo. If you know the speed of sound and the time it takes, you can find the distance the sound wave traveled. High-tech multi-beam sonar systems work similarly, except instead of listening for just one echo, microphones pick up echoes from 426 different locations every second. This reaches out to 500 meters on both sides of the ship. Computers then stitch all those echoes together, and the end result is a high-res 3D map that gives us detailed data of what's happening on the ocean floor.
So using this method, we get to know what is at the base of the ocean, which is a big discovery because we know there is a mid-oceanic ridges. We get to know deepest part, which is Mariana Trench, and people start to think why the morphology is like this. Along with the bathymetric survey, there was a large amount of seismograph network installed after Second World War, using which we get a really precise detection and more amount of earthquake detection than it used to be previously. When we observe the global distribution of earthquake, we see the earthquake occur in a particular belts. And these belts are sometimes associated with these ridges and sometimes with particular lines, which that time was not knowing, but it was speculated there is something special about this belt and therefore earthquakes are happening at these locations. After all this observation, Harry Hess was a guy who actually come up with the idea of a seafloor spreading, and he suggests that at this location, which he called the mid-oceanic ridges, the ocean plate tear apart and new magma come and create a new ocean. While he also suggests that this slab goes down, like this part goes down, and earthquakes are concentrated where these two things collide with each other. Still, he was not having a particularly firm evidences, so he was highly criticized, and still there was no such theory, not like confirmation for this theory. But later, a PhD student, Fred Wine, and his supervisor, PhD supervisor, Drummond Matthews, found out that as we move away from such mid-oceanic ridges, we get similar age rocks on both the sides, which suggests that the eruption of the magma caused formation at equal spaces, at equal distance, at equal time. All this theory were combined together. Arthur Holmes, geologist, also proposed that mantle, which is below the crust of Earth, is having a convection current, and which might be the cause of all these movements of the continents around it. And based on all this observation, new theory emerged out, which is called as plate tectonic theory, which is our today's topic. So what actually in nutshell plate tectonic theory suggests? According to plate tectonic theory, the upper part of Earth, which is crust, and some part, the rigid part of upper mantle, is combined together as a lithosphere, which is rigid and which can move around, which is sitting on a plastic asthenosphere, which is hot rock, which can move. So if you see in this diagram, this is the asthenosphere, this is the mantle convection going on, and as per the mantle convection as a driving force, the lithospheric plates are moving around. So what was said by Wagner that continents can move and they change their position with the time, it was true, and it was proved by this theory. According to plate tectonic theory, there are two types of lithospheres. One is the oceanic lithosphere and one is a continental lithosphere. Oceanic lithosphere is very denser, but it's thin, while continental lithosphere is less denser and it is thick. Based on this, basically, people map such boundaries, and they find out there are three types of boundaries which are present. These boundaries are where one plate collide with another plate, and these boundaries are divergent plate boundary, where a plate split and a magma come up and new oceanic crust is formed, and therefore it is called as constructive margins. Destructive margins or convergent plate boundaries is where a plate moves down below another plate, and this is getting destroyed, and therefore this is called a destructive margin. While transform plate boundary is where two plates are moving apart each other without getting destroyed or creation of new. So that is a conservative boundary. So based on all this study, Earth was divided into three, the whole Earth was divided into three type of plate boundaries. So wherever one boundary is interacting with another boundary, there is at least one of these boundary types. So for example, if you observe Australian Indian plate and Eurasian plate are having this blue color boundary, which is a convergent boundary. And we know that there is a Himalaya formation in this area, like a big mountains of Himalaya here. We can see in here mid-Atlantic ridge between African plate and South American plate, where the plate is getting away from each other, tearing apart, and new ocean floor is getting created. So let's see in detail each and every of this, each one of this plate boundary. So let's start with a rifting, or what we call is divergent plate boundary. There are two types of divergent plate boundary. One is seafloor spreading and another is a continental rift. So one can be an ocean rift and one can be a continental rift. In case of a seafloor spreading or a oceanic rift valley, the oceanic crust is tear apart, and the asthenosphere, which is at very close to its melting, just get near to the Earth's surface. Due to a depressurization, there's a melting of the mantle and new magma will erupt and forming the seafloor basalt. This is the animation of how magma is erupting inside the ocean and forming a pillow basalt near the mid-oceanic ridge. But if the splitting is at the continental rift, then at first a continental upwrapping happen, then there is a continental rifting, and as the rift continue, there is a formation of new type of ocean form around it. Do we have any a recent example, or is there anything happening today? Yes, there is going on in Africa, in East African Rift. This part is basically getting broken apart, and very soon there will be a new ocean forming in this area, and this part will move and collide with another plate. So let's see a small video about it.
Africa may split into two different continents in the future. Geologists strongly believe in the theory after a massive crack appeared in Kenya. The region is referred to as the East African Rift Valley. Africa may split into two different continents in the future. Geologists strongly believe in the theory after a massive crack appeared in Kenya. The region is referred to as the East African Rift Valley, and the crack is more than 50 feet deep and 65 feet wide, according to National Geographic. Forbes reports that the crack is continuously growing and heavy rainfall in the area is not making it any better. The outlet notes that scientists have been aware of the potential split for a long time. However, it will take millions of years before it fully splits apart. Experts say the smaller of the two continents would include Somalia and parts of Kenya, Ethiopia, and Tanzania, and the bigger continent will include everything else. This concept isn't foreign to researchers. An Arizona state geologist said, quote, "A rift like this once eventually separated the African and South American continents to form the Atlantic Ocean."
So it is evident from all the observation in this area that in some million years, of course, not very soon, but in some million years, this part of Africa will be bricked and it will move apart. Then let's move to the convergent plate boundary, where two plates collide with each other. So as I said earlier, there are two different types of plates. One is oceanic plate and one is a continental plate. Oceanic plate is more denser, continental plate is less denser. Because of this, oceanic plate can subduct in the mantle, but continental plate cannot. So based on this, we can have three different type of collisions. One where oceanic crust collide with a continental crust. In this case, oceanic crust will subduct. Another in which oceanic crust subduct beneath another oceanic crust, the more denser, which means the one older crust, the older plate will subduct. And when two continental plates collide, nothing is subducting. They are just getting compressed to form a big orogeny or big mountain region. So what happens in first case? In first case, when oceanic lithosphere or oceanic plate collide with a continental plate, the denser oceanic plate subduct and cause melting of the mantle, which create a chain of volcanoes, which is known as continental volcanic arc. And this is the reason for volcanism in Andes mountains and areas. If ocean interaction happen, if oceanic plate collide with another oceanic plate, then a denser and older plate will subduct. Another time the melting happen and there's a chain of volcano. Japanese islands are formed, Philippines is formed by volcanics are formed by this mechanism. While if there's a two continents like Eurasia and India is getting Indian plate are getting colliding with each other, they will form a mountains like this, like Himalaya. So let's see an animation what actually happened when this when this collision happened.
In this animation, we're going to subduct some ocean floor underneath the edge of a continent. And as that happens, as you know, you get an ocean trench, but at a certain depth, about 80 miles down in the earth, the subduction of the plate triggers melting of the mantle, and that magma rises, and a whole series of volcanoes begins to pop up along the edge of the continent parallel to the trench. We call this a continental volcanic arc. The Andes Mountains are a classic example of such a system. Now, another thing we can do is have, instead of ocean floor subducting underneath continent, we could have ocean floor subducting under other ocean floor. In this case, the animation is flipped around, but it doesn't really matter. You can imagine either of these in a mirror image. Same process. We're going to subduct the ocean floor underneath this other ocean floor. We're going to generate magma. The magma is going to rise, and a whole series of volcanic islands is going to pop up in the ocean parallel to the trench. You see how it's very similar to the continental situation. The only difference is that the volcanoes are popping up out of the ocean parallel to the trench instead of on land parallel to the trench. Okay? So an example of this would be the Aleutian Islands, say, or the Philippines, or the Marianas Islands in the Pacific. These are all what we call volcanic island arcs, volcanic island arcs.
So this is the reason we are getting volcanoes, volcanic chains around particular plate boundaries, where one plate boundary subduct beneath another, one plate subduct beneath another. But what happened when two continental plates collide? Similar thing happened while formation of the Himalaya 50 million years ago, when India, which is moving towards Eurasian plate, collide. There was a Tethys ocean. So this oceanic plate subduct, there was formation of continental volcanic arc, and later Indian continent collide with Eurasia to form Himalaya. And we have so many earthquakes in this area, in Tibetan Plateau or Himalaya, or even near the Ganga plain, because of this collision, because the plate is still moving north eastward. There was one news which is circulating for many years. I think from my childhood, I'm looking for this news that scientists have found fossils of fish on the peak of the Himalaya, which means there used to be a big ocean covering everything, which is a fake. The reason being there was an ocean here and marine life. Some part of this got scrapped off, and this is part of Himalaya now, and therefore we get a fish fossils. There was no such thing that there was a big ocean which covered all of the earth. So this is a big lie. So therefore we should know the scientific reasoning behind such stuff. Let's see the animation, what actually happened during the formation of Himalaya. So this is Tethys getting subducted, formation of continental volcanic arc. And then there is a compression between Eurasian plate and Indian plate, and formation of Himalaya, India, and Tibet. The last type of boundary is called as transform plate boundary. In this case, the two plates just move along each other or past each other with a friction, of course, but there is no formation of new magma, or there is no destruction of the plate. Such boundaries are called as transform plate boundaries. Such one boundary is a San Andreas fault. And as we see the first example or first newsletter, that there used to be there was a big earthquake in San Andreas. This was because of the San Andreas fault, and which was a big devastation in the San Andreas. Therefore, these boundaries are more dangerous, and these boundaries are prone areas where you can find a good amount of earthquakes in the area. There was some volcanoes which are far away from the plate boundaries, and no magma can be generated in this area by the subduction procedure which we previously saw. Therefore, John Wilson proposed a mechanism called as rising mantle plume or mantle plume hypothesis. What he observed is, as we move from one part to another part of such a volcanic chain, he observed for Hawaiian Islands, he see that as we move from one place to another, or from one volcano to another, we get progressively younger age. So his model is, when a plate is moving, there's a continuous supply of a magma from the mantle plume. A melting of mantle causes some melt to be rise towards the lithosphere, and it creates a volcano. But as the plate is moving over this source, new volcano is erupted, which is younger and younger and younger. And this is called as mantle plume volcanism. Hawaiian volcanoes are the best example of a mantle plume. So let's see how these Hawaiian volcanoes look. Hawaiian volcanoes are basically the laboratory for volcanologists. All types of different volcanic features, like volcanic fountains, ropey lava, lava, everything can be observed here, and therefore throughout the world, the geologists and volcanologists are attracted toward the Hawaii. And how this is formed was resolved by Wilson in his hypothesis. So this is Kilau eruption. I think it's in 2000 somewhere. This Kilau erupt. So this whole was the plate tectonic theory, which I want to tell you. I hope I tried to be as basic and simple as I can. So I hope I convey my message. Though if I have missed something, this video is for this purpose. This will summarize everything which I was talking for so much time. So let's just watch this video.
Plate tectonic theory was not accepted for centuries because no one could adequately answer the question, what is the mechanism that drives the plates? In the late 16th century, Abraham Ortelius, in compiling New World Explorer maps, noted that by carefully considering the coastlines of the Atlantic Ocean, it appeared that the Americas had been torn away from Europe and Africa by, he theorized, earthquakes and floods. Over the next 3 centuries, other proponents of an original single continent included Francois Paget, who invoked the sinking of the land between the continents to create the Atlantic Ocean, Georges-Louis Leclerc, who resurrected Ortelius's theory of a great earthquake and floods pushing the land apart, and finally Antonio Snider Pellegrini, who proposed that the shape of the continents, supported by fossil evidence, argued for the origin of a single continent, which not only joined the continents across the Atlantic Ocean, but also included Australia. No one, however, could explain how the continents moved. Bathymetric surveys in the following decades unveiled an extensive submarine mountain ridge between the continents that ran the length of the Atlantic Ocean. Meanwhile, seismic data began to reveal Earth's layers, a core, a crust mantle boundary, and a thick outer layer called the lithosphere that lay above a less dense asthenosphere. In 1912, German meteorologist Alfred Wagner, also intrigued by the fit of the edges of the continents, championed the concept of continental drift, based on his study of similar rock types, geological structures, and fossils on both sides of the Atlantic. To make it work, he hypothesized that the mechanisms causing the drift might be the centrifugal force of the Earth's rotation or the change in its axis of rotation. Wagner also speculated that, quote, the mid-Atlantic ridge is continuously tearing open and making space for fresh, relatively fluid and hot material from depth, end quote. His views were considered preposterous and improbable, and were rejected by most Earth scientists. Following the discovery of radioactivity in 1896, it became clear that Earth's interior was heated by radioactive decay, and that the insides would be largely molten. Indeed, by 1926, a liquid core was determined. In 1927, geologist Arthur Holmes, studying radioactive decay, proclaimed that mantle convection was the answer to Wagner's missing power source to drive continental drift. He based it on the fact that as a substance is heated, its density decreases, and it rises to the surface until it cools, when it sinks again. But convection of the solid mantle alone was still unpalatable to most geoscientists. Nuclear bomb testing in the 1950s motivated the establishment of the worldwide standardized seismograph network to monitor explosions, prompting a greater concentration of seismograph stations. The increased data allowed seismologists to precisely locate far more earthquakes, revealing that most occur in discrete areas, near trenches and along mid-ocean ridges. Decades after Wagner's death, geologist Marie Tharp, left in the lab to examine data from ocean floor field surveys, theorized that mid-ocean ridges appeared to be extensional rift valleys formed by plate motion, thus paving the way for the acceptance of Wagner's continental drift theory. Her colleague, Bruce Heason, initially skeptical, published her work in 1956 under his name, but ascribed the extension to an expanding Earth theory. It wouldn't be until the mid-60s that he would accept Tharp's interpretation of plate motion. Curiously, it was Harry Hess who, in 1962, was credited for recognizing that oceans did grow from spreading ridges. He also defined ocean trenches as locations where ocean floor was destroyed and recycled, but he too lacked geophysical evidence to confirm this theory. Just 1 year later, this concept was supported by ocean floor magnetic surveys that revealed symmetrical patterns of magnetic striping on either side of the mid-ocean ridges. These stripes were found to be the same age at similar distances away from the ridge on each side. While pondering the mystery of how volcanoes, such as the Hawaiian island chain, could be so far from spreading ridges or subduction zones, Tuzo Wilson proposed the plates moved over hotspots. Following this breakthrough, with the discovery that ocean ridges were connected with transform faults. the science rapidly blossomed with the definition of the three main plate boundary types: divergent margins, where plates move apart; convergent margins, where plates push together at subduction zones or mountain ranges; and transform margins, where plates move horizontally past each other. As geophysical evidence supporting plate tectonics accumulated during the 1960s, scientists revived Holmes' theory of mantle convection as a driving force for moving the plates. Mantle convection assuredly plays a role, but it doesn't explain how some plates creep along faster than the convection currents beneath them. This led scientists to a fundamental force: gravity. Gravity acts on the tectonic plates, resulting in what are now referred to as ridge push at the spreading ridges and slab pull beneath subduction zones. This is an evolving science that not only involves these three forces, but involves friction and much more, leaving scientists to ponder: what will be the next tool that helps reveal new facets of plate tectonics?
This is pretty much about this theory. This theory answers many of the questions which are in front of human beings, like why earthquakes happen. Mostly earthquakes happen in the mid-oceanic ridges or where there is a subduction. Why volcanics happen. We just saw that because of the island arc formation or in mid-oceanic ridges. And that's everything about this theory. Is still going on. People are researching more and more about it. We are working on it. So yeah, pretty well everything. These are some books and documentaries. This is the biography of Alfred Wagner. This is a biography of David Johnston, who died in one of the volcanic eruption in St. Helens. This is a Fire Within documentary about a couple who was working on volcano, and this is one of my favorite documentary about volcano at Nyiragongo in Africa, where they did a extremely dangerous but interesting exploration of volcanic eruption. So thank you for listening to me. I hope I've answered some of your questions, and I'm open for the questions.
Projekt GEOGADKA – Geofizyka dla każdego jest współfinansowany ze środków Ministerstwa Edukacji i Nauki w ramach programu Społeczna Odpowiedzialność Nauki.